All right, so we're going to look really quickly at the desmos for these functions, these rational functions or reciprocal functions. So we can see in red what we have is the parent function. Again, I've got points such as, hold on, let's see if it'll highlight it. I've got points such as 1, 1. I've got 1/2 and 2. I've got 2 and 1/2, and so on and so forth. Okay, so again, we can see no matter how much I zoom out, you can see that our graph is actually never going to cross either the x-axis or the y-axis. They look like they get infinitely closer, and in fact, if I go out here, for example, and I zoom in as far as I can, right, look how small these numbers are, you can see that we still have space between the graph and the axis. So that's why these are called horizontal, or these are called asymptotes, because it gets really, really close, but never quite reaches it. Sorry, that should have been. Here we go. Okay, let's just go. Okay. So now, if I want to transform this guy, all right. So our general rule for transformations, all right, looks a little bit different than it has before. Okay. The only difference this time is that my h, right, is gonna, you can see it's in the denominator. It's gonna be with my x. So my h is always gonna be attached to my x at the hip. Okay. You can see too that if I just multiply this a to the top, just like I normally would functions, you can see that this a over x minus h plus k, these two are actually the exact same thing. Okay. So what happens is, just like normal, right, if I go ahead and I increase my a, greater than 1, right, you can see how my graph starts to stretch and pull away. But if x or a gets between 0 and 1, right, you can see that it starts to shrink and just gets closer and closer and closer. But notice here that it's never actually going to get, right, unless it's 0, it's never actually going to get to 0, 0. Now what happens when if a is negative and this thing flips? Bam. Notice how it essentially reflects across the x-axis. Okay. It also looks like it's the same reflection across the y-axis. So this is why we're not introducing b, because a and b are kind of doing the exact same thing once again. Okay, but again, as a is negative, greater than negative, or sorry, less than -1, right, we can see that it starts to pull away, but it's still flipped. And if a is between -1 and 0, right, we can see that it's still flipped, but it's compressed as well. Okay, so if I go back to 1, right, phase 1. Now you can see. Now let's see what happens when I move x or h and k. So again, same thing's going to happen. If I move h to the right 1 unit, right, you can see now that we're starting to just shift this graph. It's the exact same way, but I'm just starting to shift it. But one of the things that I want you to notice, right, is that if h is 2, for example, notice here that we actually do have an x-intercept, a y-intercept, if it'll let me touch it. Right? We actually do have a y-intercept. Okay, it's at 0, -0.5. And we're going to solve for that in the next video, right, and be able to figure out how to calculate that. But notice how it still doesn't have an x-intercept, but it does have a y-intercept. Okay, and all I did was move h. Okay, but you can see now, where's my asymptotes? Right, I know it's kind of hard to see here, but our asymptote is actually at equals h. We'll actually make this little dotted line here. Okay, we actually have two asymptotes at x equals h and y equals k. Hold on, I'm trying to get this thing. There we go. Okay, so notice here when I move my h, right, all right, my horizontal asymptote or my vertical asymptote shifts, right? And my x, or my horizontal asymptote, is wherever at h is equal to. Now, if I move k and I move this thing up, right, you can see that my the center of, or where my two horizontal and vertical asymptotes cross, right, is at where h and k is. Okay, so this spot right here, which is at 3, 5. Okay. Now again, in this case, since we have both h and k, we do actually have, right, a horizontal, a y-intercept and an x-intercept. So we have to be really careful. Our h and k are actually, when they shift these around, right, we may or may not actually have x or y intercepts. Now initially, if h and k are both 0, we don't. But once I start moving them, then you'll start to see that we actually do have intercepts, and that my asymptotes are actually the ones that are changing. Okay. Anyway, so I'll leave this video, or I'll leave this Desmos with you guys on Canvas, so you can kind of play around with it. All right, but this is just kind of the idea for our transformation. So again, I'm not going to list it out and define it because it's the exact same ones that we've been working with for a long time. Okay? All right, thanks for watching, guys.